It's now time to explore the second part of the fundamental theorem of calculus. The fundamental theorem of calculus part 2 will always be connected to functions f of x that look something like this, where it's defined to be the definite integral from a constant to a variable. This type of function is called an accumulation function because we think of it as the accumulated area under the curve from x equals 0 to any x value. The fundamental theorem of calculus part 2 states that if f is a continuous function on the interval and f has an antiderivative on that interval, we can define big F of x to be this accumulation function, the area under the curve from a to x. If we want to find the derivative of big F, the derivative of big F, it is going to be the derivative of this accumulation function. And if you're taking the derivative of an antiderivative, you should end up with the original function. So ultimately, what this is telling us is that differentiation and integration can be viewed as inverse processes. But let's demonstrate why this is even true. Let's say over here on the right, I want to find the derivative of this accumulation function. Let's say we didn't know the fundamental theorem of calculus part 2. The first thing I would do is calculate this antiderivative. So this would be the derivative with respect to x of 1/4 t to the 4th from 1 to x. So this is equal to the derivative with respect to x of 1/4 x to the 4th minus 1/4. That's using fundamental theorem of calculus, part 1. So now I need to turn around and take the derivative of this function. Well, the derivative of 1/4 x to the 4th is going to be x to the 3rd, and the derivative of negative 1/4 is 0. So what we've shown is the derivative with respect to x of the integral from 1 to x of t cubed dt is just x cubed. So notice all we ended up doing is taking this variable and replacing the initial, they call it a dummy variable, but the initial variable of that integral. Now, this is only true if the bottom is a constant, must be a constant, right? Because if the bottom is a constant, then we know that derivative will go to 0. Derivative is 0 if lower limit was a constant. So we can see anytime we take the derivative of an accumulation function, we take this variable and plug it in for the one in the initial function. So we're going to use part 2 of the fundamental theorem of calculus to find the derivative. So remember, before we can use FTC part 2, this bottom must be a constant. It is. And it's going to a variable up top. That variable is just going to replace the variable in my integral. So my answer here would be sine of x squared. No work needed because we're using the fundamental theorem of calculus. Same thing here on part B. I'm taking the derivative of an accumulation function. The bottom is a constant. That must be the case before you can apply FTC part 2. So I'm going to take this variable and replace this dummy variable with it. That is going to be e to the square root x. No work needed because we understand that taking the derivative of an antiderivative is just an inverse operation and will leave the starting function.